All right, today we're going to be looking at section 4.2, graphing polynomials, and I'm going to highlight the key information, and then we're going to jump over to my math lab and start working those problems. So we have two objectives. One is we're going to graph polynomial functions, and the second is we're going to use the intermediate value theorem to determine whether a function has a real zero between two given points. So the first objective here, graphing polynomials, we are given that if you have some function and they're using p of x to denote the function, sometimes you see f of x, but p of x is a polynomial function, has degree n. The graph of the function will have these properties. One, at most n real zeros, so the highest degree is going to be the maximum number of zeros, and that same number of x-intercepts at the most, and then at the most it will have n minus 1 turning points. So when the graph changes direction, have a maximum or minimum. When it changes directions, you'll have n minus 1 of those. All right, so that's the first objective. We'll see some examples. So if you had a fourth degree, it'll turn around, maybe 3 times, but it'll end up going the same direction. And here are some samples that you can kind of see and go over. I'll spend the time going over those when we do the problems in my math lab. Here's another example. They're kind of showing you intercepts and maximum or minimum. Here is a box that kind of gives you the steps to graph a polynomial. So use a leading term to find the end behavior, find the zeros, use x-intercepts or zeros to divide it into intervals, and then we'll choose point to determine the sign of the function in that interval. Find f of 0, so that's the y-intercept, and then if necessary find additional function values to get the general shape, and then as practical, you're going to check the facts of the graph. Okay, so that's the process. Here again, some other examples and test intervals, which you'll kind of see as we get going. Another example. More examples. And then the intermediate value theorem. So this is a difficult read, okay, but it's really a simple concept. So if you were reading the definition for the intermediate value theorem, it says for any polynomial p of x with real coefficients, suppose that a is not equal to b, p of a and p of b are of opposite signs, the function has at least one real zero between a and b, and the intermediate value theorem cannot be used to determine whether there is a real zero between a and b when p a and pb have the same sign. Okay, so that's really difficult to understand, but here's the simple of what's going on. You're going to have some function, okay? A and b are going to be x values. So you got two different numbers. All they're doing is saying they're two different numbers. They're not the same. So as you can see from the diagram, we can put a as a smaller number and b can be a larger. They're separate. Okay, when we plug those in, a will lead to some y value, so they're denoting that with p of a, and b will give us some y value, so we're denoting that with p of b, and if the sign is different, so when you plug in those two x values, a and b, and you get two y values, if one y value is positive, they're showing you greater than 0, and the other one is negative, then that means at some point between a and b, the graph had to cross 0. That's all it's saying. So that means we're guaranteed to find an x-intercept. So there's one real 0. So if it goes from positive to negative, it had to go across 0. So that's what this is saying. Sometimes the graph may dip below and then come back up. If we don't have the graph and we're just using the function, we can't really see what's going on. And if both of those signs are positive, we don't know, because the graph could have been positive the whole time. It could have went below and came back up. But the intermediate value theorem only guarantees a 0 if we know the signs are different. Okay, and you can see some different examples here. And so, again, this is assuming we don't have the graph. This is just using the function to determine if we have a 0. All right, so those are the objectives for this graph. You can kind of see some different functions. We're going to go ahead and jump into my math lab.